so let's look at your worksheet. Let's go through, I'll go through the notes first, and then we'll go through an example. Okay, and the example is going to be who prefers McDonald's more, males or females, or who prefers Wendy's? I think we do Wendy's fries. Males or females? Okay, that's what we're gonna test. Two sample proportion Z interval. It's not a test, but a Z interval. You can see why I have said that you should make sure that you know how to do the calculator shortcut, because this is not something that you want to have to type into your calculator step by step. My guess is in a rush you will make a mistake somewhere. It's easier to use a two-sample Z proportion on your interval on your calculator. It's super easy at that point. Okay. By the way, I am recording this, so I will put this probably on YouTube. So if this is a lesson I wasn't sure, I'd like to go back and review. Just go to Mike, YouTube, Mike Flourish, not Michael or Mr., but it's Mike Flourish, and then I have a channel. One of my channels is an AP Stats channel. Okay, so know that. I don't know if I put a link to it on Moodle or not.
Last time we did.
But do I have it to the
It went
to the channel?
YouTube. Yeah, and then
Okay, so there might be still a link on it. Okay, so I'll probably put it under there, just in case you want to review it again, or if you know some of these people that are gone, this is a lesson they might want to walk through. Okay, just know that it'll be there. All right. First thing you got to do is we got to look at the successes. What's P1 and P2? P1 is your successes for the first set of data, whatever that might be, and it's your number of successes over the total count. Just like you would if I said, what'd you get on your packet yesterday? You say I got 13 out of 23, 13 correct out of 23 total. So that's not anything to blow you away. It's just what is the sample proportion for the first set of data versus the second set of data. Same kind of deal, x2 over n2. I'm interested not in p hat anymore. I'm interested in the difference between the two. Is there a difference between p hat and 1 and p hat 2? That's what I want to know. That's what I would look up. So p1 minus p2 hat, that'll give me my center part that I'm looking at. Plus or minus z star, 1.96, 2.576, 1.645. Nothing new there. You know that. This gets kind of ugly. But notice everything is p hat 1s and 2s, right? All of this part all right here is all 1s, plus, don't forget it's plus, all 2s, and it's all p hats, right? We don't have any p, we don't have a p combined, which we're going to learn about in a couple days. It's the same thing as when we did a one proportion z interval. It was all p hats. No p's were involved. I don't know if you remember that. Okay? Assumptions. Still, is it a simple random sample? Is it approximately normal? That hasn't changed. Look what has changed, though. It's n1 times p1 greater than or equal to 10, and is n2 times p2 greater than or equal to 10. I have to test actually both sets of data now. And n1 times 1 minus p1. Okay? I have to test both of those. So now you have 4 things to test for normality. Independence. 10, is the data independent? Did we replace things? If not, then I have to test 10n less than the population, but for both sets of data again. If one of them doesn't work, one of these, for example, don't work for your normal, then you can't do the test. Or you would say proceed with caution. In terms of this picture, they're going to start talking about center, shape, center, and spread again. What part of this do you think represents your shape? What part of this, when they say, what kind of shape do you have and why? Okay?
With the normal test representation.
Right there. You're testing for normality. If these 4 rules hold true, then you have approximate normal situation. There's your shape. What about the center? Who's that? Good. Why? Exactly. That's where your interval's centered around, right? It's this number, and then you got your margin of error both sides of it. So that makes sense that your center would be the, what is it centered around in terms of your interval. And what about the spread? What was the spread before? Anybody remember? Not the margin of error, but the standard error. That part right there is your spread. The standard error part, not including the z-star. And I can go ahead and do this. Go back to binomial distribution. I can find the standard error right here as long as the independence rule holds true. We've had that back when we did binomial, but just kind of bring it back up as review. Questions on any of those? Stop me at any point if you have a question. So we're going to do an example next. Can I move on? All right, take out your calculators. Help me through this. We're going to do a two sample proportion z-interval example. Who prefers Wendy's fries more, males or females? What do you think from our data? Anybody have a guess? Males for Wendy's over McDonald's compared to females? Don't look at number. We're looking at proportion. Okay? So Alexa says females. Some people might say males. It's really hard to tell at this point, right? Wouldn't it be nice to have a test to prove it? Well, that's what we're doing. Okay? Let's let P1, P hat 1, do you know right now what it stands for? No, so we should make sure the grader knows that that's males. P hat 2 is females, so write it out. They're going to be looking for that. And then from here on out, you can just do PM, P hat F, kind of throughout the rest of it. As long as you've defined it, now you can do the shortcut. All right, number of successes. How many successes did we have for males? We had 15 that liked Wendy's. Agree? So 15 is my top number of successes out of total males. We've got 15 plus 43, so 58. Somebody want to find that on your calculators? 0.2 something. And let's do the females. What do we have? 13 out of 39? $15 out of 58. Anybody got it? 0.258 or something? 25. Yeah. Is that 25? Let's go 258. And this is going to be a third, right? 0.3 repeating. 13 out of 39. Is there a difference? Females looks like preferred over males. Do we have significant difference? That's what your test would do. Right now, I want to know, on average, what is the proportional difference between them? Okay. Parameters, proportion of males and females who prefer Wendy's fries. Assumptions, assume it was a simple random sample. I went through and had people do that. Approximately normal, N1 times P1. N1 is 58, because we're doing males, times success, which is 0.258, which is just 15, which is greater than or equal to 10, so we're okay there. Right? It's just really that number. And then N1 times 1 minus P hat, so we're talking 0.742. And we're going to get what's ever left over, which is going to be 43, which is greater than or equal to 10, so we're okay there. So for males, do I have a big enough sample size? Yes. How about for females? N2, we had 39 times 0.33, which is 13, which is greater than or equal to 10. Or you can just say 13, because that's the top number of successes. And 39 times 0.67, which is going to be what's left over, so 26, which is greater than or equal to 10. Are we okay? Yes. I actually did this morning after I gathered all my data. I just wanted to see what was going to happen. And I went through all 4 of these tests, and this one right here was 9. Everything else was okay, but this one wasn't. This one was a 9. So at that point I said, oh, we're going to have to go through it and proceed with caution. I'm like, oh, I wish I could get a bigger sample size just to take care of that. Well, there's a class in here first hour. I don't teach it. There's an Algebra 2 class in here first hour, so I asked the teacher just to have them on their way out, mark it if they don't mind. And that allowed me to get a few more females to put us over that 10. So all I did was, in real life, that's what's going to happen. If you go through and you're not going to proceed with caution, you would stop in real life, go get a bigger sample, and then take care of your data. Okay? And that's exactly what I ended up doing here. All right, so normal, are we good? Approximately normal? Yeah. Independence is 10 times 58, which is 580. Is that less than the population of males? I don't think we have a problem there. How about 10 times 39, which is 390? Is that less than the population of females? Shouldn't have any problems there either, right? So my assumptions are all okay. That allows me to go ahead and proceed with doing an interval. Any questions on this page? The hard part's done, in my opinion. This stuff right here is where people make the mistake. Especially as we get into a two-proportion test, they keep putting the wrong numbers in here. So you're just going to want to make sure that you understand that it's all P1s and P2s. In a couple days, I'm going to teach you a p-hat combined, where we combine all the data, and that throws things off. So just realize this is all P1s and P2s. We good to go? All right, let's fill in the data. I think this is on the flip side, right? P-hat 1 was males, 0.258, minus 0.3 repeating, plus or minus, this was a 95% confidence interval, so 1.96 times the square root of P-hat 1, 0.258, times what's left over, 0.742, all over its sample size of 58, 58, plus the females, which was 0.33 times 0.67 over their sample size, which was 39. Now look how ugly that would be to type in. It's easier to go to your calculator. Let's go to the shortcut. Two sample proportions, the interval, not the test, but the interval. That's what we're doing. I think it's B. It's easier to scroll up, I think, now, because we're so far down. It's easier to scroll up and get it. Hit enter. It asks for X1 and N1. Here's your X1. Oops. Here's your X1 and N1, the 15 out of 58. And then it asks for X2, N2. There's your X2, N2. Notice we're not putting the proportions in there. We're putting the actual numbers in there. It will find the p-hats for us. Confidence level 0.95. Calculate. What do we get?
Negative 0.2607 and 0.11127 if you want it.
That's a huge interval. But it's the interval we found. In conclusion, I am 95% confident that the true difference in proportion of males versus female and who prefers Wendy's fries is between negative 0.2607 and 0.1113. And therefore what? Remember, there's some parts that have to come into play here. I'm 95% confidence. You have to give the confidence level, right? That's worth a point. In the context of the problem. The context of the problem there is the true difference. Now, this is kind of the word difference. In proportion of male versus female who prefers Wendy's fries. There's the context of the problem. But now we're talking about the difference between two different proportions, male versus female, is between, and then you got your actual numbers. There's your third point. And therefore what? Anybody know? What have we found? It's kind of hard think about it right now, right? Wouldn't it be nice to have a null and alternative to kind of give us some direction? So go ahead and do that. What do you think your null would be? Just, you don't have to do it, you don't have to write it down. It's not part of the test. It's just sometimes it helps you think through it. Proportion of males is equal to the proportion of females. Isn't that kind of what we're wondering? The alternative is that what, males is less than females? That's kind of what I'm thinking through. Can't this be rewritten as male minus proportion of female, and this should be hats, is equal to 0? Yeah. So, what do you notice?
The 0 falls in the range.
Yeah. 0 falls in this range without any problem. So do you think I'm going to come up with significant evidence that there's a difference? No. Even though it looks like it, 33 versus 26, or versus, 26, right? Your 33% versus 26, that's a pretty big difference. It's just our standard error came into play and made it not so significant. I mean, that's a huge margin of error. But bottom line is I do not have evidence that one is preferred over the other, male versus female. So, and therefore, I would put in here neither prefer Wendy's fries or McDonald's, if I had to take a guess. Questions on any of those steps? To me, this part right here is the easiest. If you can memorize this part's the easiest. Everything else is just same thing over and over. It's just you got to be able to piece it together. Okay? Now, question?
Is there a quick question?
Okay, let me get to it in a little bit. Let me get through this. Out of this whole thing, either this page or this page, what is the scariest thing? What scares you the most?
The standard error.
The standard error part? So you're saying this part right here, it's kind of scary? I agree. This part is just what's the difference, right? But, that's, I guess, not too bad. It's this with all these P's flying around. Take out your College Board sheet. I'm going to show you why it's really not going to be that hard. Everything is there in front of you on your College Board sheet. So what scares me the most about this is people going through and, I don't remember how to set it up. Part of this is already here for you, okay? You just got to understand where it's coming from. You're dealing with the confidence interval, right? Which is your statistic, which in this case is, what's the difference? P hat 1 minus P hat 2. Otherwise, it would have been P hat, X bar, right? What if we get into a 2-sample T test, or T interval? That's not P, those become what? Those become X bars, right? X bar 1 minus X bar 2, because you're dealing with numbers, not proportions. So it's always a matter of, what am I working with? That's your statistic. What is it centered around? Plus or minus the critical value. What's your critical value? Z star or T star. It's the only things that we've had. And then your standard deviation. That's the part that I highlighted, and that's kind of ugly. Except that your standard deviation is right there. So you really don't have to memorize it. Here's your standard deviation for a 2-sample Z. Here it is for a proportion. This is when we go to do tests, and that'll come back up in a couple days. So I'm teaching you 4 over the next week and a half, but they're all really going to be right here. All this part right here is what we're working with. Whereas when we did a one sample proportion and a one sample test, z-test or t-test, there's your standard errors, right? There's your standard deviations. This would have gone here, this would have gone here. Otherwise, everything else is the same. So you got to realize just how is the College Board written to help you. And that's why I really want to, I'll try to emphasize that, make it a little bit easier.